So a lot of people have been requesting a video on how to make custom startup tones for your BLHeli ESCs. I've got a couple videos out there where I show the Top Gun theme song and the Lego theme song. It's just two songs that I've kind of created and put together as startup sounds for your BLHeli ESCs. And I took inspiration from some of the other videos out there where you can do the Game of Thrones theme song as well as the Star Wars Imperial March. So that was all in a GitHub project, so I decided to fork that and create my own version, and I'll show you here how to come up with your own startup sounds and hopefully make those available for all of us in the hobby so you can do some neat things. It's recommended that you have some music theory background because you'll have to read music, at least that's the way that I did, and then do some coding to convert those notes into assembly language to get the ESCs to actually play those tones. I'll show you a little bit of that, but there will have to be a little bit of work on your part to pick a song, find the notes, and then convert that into assembly language that then you'll compile into a hex file that's loaded to the ESCs. So I will show you that. If I leave anything out, leave a comment and let me know. And hopefully this will make a little bit of sense to the programmers out there. So it's all based around a couple different software packages that I've already downloaded. So one of them is Simplicity Studio from Scilabs, and so this is the development environment for the ESCs, although we will not actually use this to do the development. We'll just use this to set up the development kits and packages that are required to compile the files into the hex files that can be read by the ESCs. You can fork my GitHub project here that has the Top Gun and other theme songs that I've created as well. And you can see I've forked it from this Clean Flight BLHeli multi-shot project. And then, of course, you'll also need your BLHeliSuite application to load the firmware onto the ESCs. And finally, the last link that I just like to use is this Audigy Music Share. It shows you very simple notes for some of the theme song. If you go and try to search for other theme songs, it might show you the full music for it, which you really don't need. You just want everything broken down to individual notes. So first things first, download the Simplicity Studio, and you will have to register to be able to download this. I'll put links in the description of the video, but you come here, click on your operating system. In this case, I'm using Windows. So you click on that. It will take you to a registration page. Once you register and confirm your email, you'll be able to log in and download the software. And I've already done that. So I've got my install file here. I'm going to go ahead and install this. And I'll come back in a second after it's been installed. I'm just going to accept all of the defaults for the installation, and I'll show you once I get back in. Alright, so now I've got Simplicity Studio installed. After it gets installed, the first time you open it, there'll be a license agreement you got to click accept on, and then it will ask you if you want to log in or skip the login. You can go ahead and skip the login or log in with the account you registered with. It doesn't matter, it'll work either way. And then after you get past that, it will download the repositories for all of the additional packages and tools that you can install for this, and you'll be presented with this install wizard. Since we're not going to be actually using this to do our development or write stuff to the board, we can go ahead and click cancel. And then we're going to open up the settings window. And then in this preferences window, we're going to go into the find this thing again. We're going to go down under SDKs. So Simplicity Studio SDKs, and then on this link here, the Need More SDKs, customize your installation. We're going to go ahead and click on that. It will load up the repositories here. Go ahead and click next. Sorry, it's been a few months since I've done this. And we're going to need 2 items here. We're going to need this 8051 IDE. So we can go ahead and click that checkbox. And then we're going to need this Keel 8051 toolchain. So go ahead and click on that. And then we'll just go ahead and click on finish. And you'll see it'll give you some videos, but then it's going to go ahead and fetch and install these packages. Alrighty, and after it's all installed, you'll want to restart Simplicity Studio, so we'll click yes. Alright, Simplicity Studio restarted. You'll get this tour message, and you notice you've got more menus and different options, and that's because we've installed that 8051 IDE. So we'll go ahead and click exit the tour, and then we'll go under help, licensing, and you should see this Keel 8051 version 9.53. We'll go ahead and click on that. And when you click on this, you'll see to activate, complete this form in your browser. And what you'll do is click on this form. You'll have to register, put in some information, and then you will get an email from Keel that has a license key in it. And once you get that, you just paste that license key in here. Click OK, and you should get this message. If you tried to build without licensing it, the BLHeliS files they exceed the size limit of the evaluation license, so you won't be able to build it. But fortunately, it's all free for you if you just go through that registration process, and you'll be able to build it. So now once we've got this installed, we can exit Simplicity Studio, and really we are completely done with Simplicity Studio, and we'll move on to the other development. Alright, so we've got everything set up for the Keel compiler, the 8051 compiler, and now I'm in my BLHeliS folder here that I've got all my software packages in, including the extracted version of the GitHub repository. So this is the zip file that you download from GitHub. I've extracted that into this folder, and I'll show you the contents of that. I really don't mess with any of these unless I'm putting it back up to GitHub again. But everything that we're going to do is inside this BLHeli_S Scilabs folder. Alright, so you'll see we've got a couple folders here, the hex files. Actually, in my repository, I have a folder with all of the original hex files that were created from the repository that I forked, so that I can have access to those if needed. And then there's primarily going to be just a couple files in this that we touch. The main one where we're going to do everything is in this BLHeliS.asm file. But before we go into that, we've got these make files here, and if you're on Windows, these are batch files that will go through and build the code into the hex files for your ESCs. So what I've actually done is two of my test ESCs that I've been working on are the AH version and the GL version. So I've created kind of a pared down version of the make hex files batch file so that it only builds that type of ESC. It just makes things run faster for my testing, but this make hex files document here will build for every type of BLHeliS ESC out there. So I'll go ahead and show you that because there's something that we need to set up here, and I'm just using Notepad++ as my development environment. So this is what the make hex files.batch file looks like. You've got your parameters here, your revision. I've just left it at 16.6.5. It looks like the way they run the revisions here is the latest BLHeliS version is 16.6. So the one with the custom startup stones, we just tack a 5 onto the end of it. And then this is the most important thing here. If you followed my instructions, it should be in this location, but if you changed any of the default installation paths, you will have to update this variable here to point to the location of the Keel 8051 binaries. And I'll show you that if I'm on my C drive, Silicon Labs, Simplicity Studio version 4, developer, toolchains, Keel 8051, 9.53, and then you just point it to the bin folder. And I've got that set up here. I will show you here real quick this file for AH. If you compare this to the regular make hex files, you'll see a whole long list of ESCs that build. This is configured to just build A_H. And so we'll go ahead and build that just to show you how to compile everything right from GitHub without making any code changes. Alright, so now we're ready to build the files that came from GitHub. Here's a little trick that I like to use. I like to go one step up. I'll hold down the Shift key and right click. And one of the options when you hold the Shift key is open command window here. So if I click on command window, I'll open it directly in that folder location. If I do a directory command, you'll see all of the information, all of the files in that folder, including these make hex files AH, make hex files GL, and your make hex files batch file. So what I'm going to go ahead and do is I'm just going to type in make hex files A_H.bat. Alright, press enter. It's going to give you this prompt. Those cannot find the file path specified is just because the output directory did not exist yet. So it goes ahead and creates it, and then when you see these compiling, if you don't get any errors or warnings after this, it means it compiled these successfully. Then you just press any key to continue, and it will exit out. So now in this folder, you should have an output folder, and in here you'll get all of the files that it generates when it performs the compile, but then you should have this other folder that is hex, and here are all your hex files for that ESC. And if you ran the regular make hex files.batch file, you would get a huge long list. It would probably take, I don't know, 4 to 5 minutes to compile all of them, but you'll get a hex file for every version of BLHeliS ESC that's out there. The one extremely important thing, if you're working on code, extremely important, check the properties of these files. I have found, and I don't know if somebody can check me or correct me on this, but if you get above 20K, it doesn't work. And you'll see this if you try to upload the hex file in the BLHeliSuite and the revision is something weird. If it doesn't say revision 16.65, it's probably the size issue. So keep this value underneath 20,000 bytes and you should be all set. Alright, so now that you know how to build and compile the BLHeliS software, let's go ahead and I will walk you through the locations where you can update things in the assembly file to actually get it to play custom tones. So I'm going to go ahead and open this BLHeliS assembly file in Notepad++, and you'll see this huge long file. Fortunately, we don't have to touch much of it, and I don't want to touch most of it because I don't want to mess with the actual performance of the ESC. I just want to mess around with how it starts up and what noise it plays when we first plug in the battery. So let me jump to line 3811. You'll see these comments here that this is where the ESC startup tone logic starts. Alright, so this is all controlled via the beacon delay setting of the BLHeliSuite configuration. So depending on what you choose, and this is on the README on the GitHub page, certain values will correspond to the certain songs. Otherwise, it just performs as normal and it plays the default startup tones. Alright, so what you'll see here, and I'll try to walk through this code as much as possible. These moves, decrement, and these are jumps, and then these are sets, and then these are kind of an else jump. And I'm probably doing a terrible job explaining this. I'm not a great assembly programmer. I just kind of followed the patterns in here and figured stuff out and played around, and used a cheap dummy ESC on this little rig that I set up to test loading hex files, and I really didn't care if I bricked it, but fortunately I never did. So what you'll see here is this tone selection method looks at the beacon strength and based on that jumps to one of these startup routines. And so you'll see all of my, so this is Mary Had a Little Lamb, the Lego, Top Gun. This is one of the default ones, the crazy tones. This is the Imperial March, and this is the Game of Thrones tune. So let's just take a look at the Imperial March one, because it's probably one of the simplest ones to show you to get the idea. Is it's just playing music notes. So it's calling these functions. So this is just calling a function to wait 200 milliseconds, and then it's going to play an F key. So this is F1, and you'll see these different Fs. So these are all the F key on a keyboard, and these are just different Fs on the scale from what I've seen. So this is, we'll play the first note, wait for 100 milliseconds, play the second note, wait for 100 milliseconds, play the third note, wait for 100 milliseconds, and then back to back play 3 notes pretty quickly, wait another 100 milliseconds, and then call the 4 notes at the end, and then we just jump to, at the end of every one of these, we jump to the normal startup routine to actually initialize the ESC. Alright, so now I've jumped up here to line 3547 in the code, and these are the music routines. And so these are comments in here for these registers, the temp 3, temp 4, temp 5, the length of the tone, the number of delay loops, so basically the frequency, and then the octave or range. So these different routines are the notes that you can call from one of the routines at the bottom that actually plays the song. So this is an A, and I don't know if the 4 means really anything to me. I kind of just experimented, but the number indicates kind of the octave of where it is. And then this A4 underscore short, so that's what the SHT stands for. This was 220, this is 100 for the length of the tone, so that's a short A press. So here's an A sharp, an A sharp for longer. I see a B key, E key, the different F keys, G, C, D, a D on a different octave, D sharp, E. So you can go through and find kind of what notes are being called here. And then you can just experiment with the length of the tone, the frequency of the tone, and then what octave you want it in if you needed to create a different tone to use in the song that you're trying to program. So you just create these music routines, and a lot of trial and error to get it to sound right on the motors. Alright, and finally, how do you find out what notes to play to create the song that you want to use as your startup tone? This is where I use that audigy.com/music share site to get the list of tones that make up some of the popular songs. So you'll see here the Lego Movie, Everything is Awesome. This is probably what inspired me to use this as one of mine because it's just right here on the home page. But you can search all throughout this site for almost any type of song. But if you click on this, what you'll see is this little utility will load. It will show you all of the notes with the name of the note here. If you read music, it makes things a lot easier because you'll understand what these timings mean, and actually how to play the song. But you can also click on the play button and it will so it'll play it for you, so you get an idea of the beats here. Yeah, so that's pretty much it. You just find a song that you want here or any other site that kind of breaks it down to just individual tones rather than chords and all kinds of things that really you wouldn't be able to encode as beeps on a motor. And it gives you the name of the key here. If for whatever reason the key is not already defined in the assembly file for the BLHeliS firmware, you'll have to play around with the frequency and the length of the tone to try to get that perfect. So that's how I put together the custom firmware to make custom startup sounds. It's pretty involved, but hopefully this video will help set up your development environment and find songs and work through the code to create your own startup tones that you can share with everybody. As I mentioned earlier, if you have any questions or comments, please let me know and I will try to answer as best I can. Have a good one.